Yeah, this question is from taken from irodov, and this is about oscillations. They gave that the body of mass m fell from height h under the pan of a spring balance. The masses of the pan and the spring are negligible. The stiffness of the latter is x. Let's take the stiffness as k. Having stuck to the pan, they gave that it stuck to the pan just after the collision, we can say. The body starts performing harmonic oscillations in the vertical direction. Find the amplitude and energy of these oscillations. Okay. They asked, so finally they asked the amplitude and they asked the energy of this oscillation. So initially you can say this is the spring, this is the pan, and here the object is there at a height of h. When it is oscillating, the object must be oscillating up and down, and there will be a mean position where the acceleration is equal to 0. Let's say the block of mass m and the gravity will be acting on that, so the force acting by earth will be mg, and also the force applied by spring equal to k, and let's say the compression equal to x. In equilibrium position, the acceleration will be 0. Since the acceleration will be 0, kx should be equal to mg. So kx should be equal to mg, means x equal to mg by k. This is the compression of the spring from initial position, that is original position, in equilibrium position. It is the original position, and this is in equilibrium, in natural state. So this is x equal to mg by k, and so finally it looks like something like this. This is a block, this is the original state where the spring was, and this is from where the block was fell. So this is equal to h, and this is equal to h equal to mg by k. So here block will be having some kinetic energy, and also that will be equal to the energy of the oscillation, because there will be no potential energy in oscillation at its mean position. You might have a misconception of having that potential energy in the spring, but in mean position there will be no potential energy, there will be the only kinetic energy, and that is equal to the energy of the oscillation. So if we take the if we see the energy of the block, it lost m into g into h plus mg by k. This is the energy lost that will be stored into the block, and there is also some compression in the spring, so there will be having minus k into mg by k whole square. So if we take the mg common out, h plus mg by 2k, this is the energy of the oscillation. And also if we see the if we need the amplitude, then it will be equal to half k into amplitude square equal to the energy which is also equal to mg into h plus mg by 2k. So if we take that k that side, and then it will be equal to a square equal to 2 mg into h by k plus mg 2 by k square, and amplitude equal to 2 mg h by k plus mg by 2k square whole power 1 by 2, and this is equal to amplitude.